I'd like to thank everybody who's joined the call this evening. Thanks for the opportunity to present to you, and also to NAPIT as well for giving us the opportunity. As Matt said, Matt briefly introduced us a moment ago, but my name's Chris Pack. I'm the Portfolio Manager with BEAMA for the Building Electrical Systems part of the business.
Yeah, good evening everybody, and I'm Paul Norris. I'm the Manager for Codes and Standards at Eaton Electric. I'm also the Chair of the BEAMA Technical Committee, responsible for circuit protection products such as circuit breakers and RCDs. As Matt has mentioned, the main subject of for this evening concerns RCDs in relation to the changes contained within the 18th edition of the wiring regulations. The format is that Chris and I will go through the presentation and we will answer any questions at the end of the session.
Okay, firstly, a little bit about BEAMA. Who are we and what do we do? Well, BEAMA is a leading trade association. It's been around for over 100 years. The organisation represents approximately 200 manufacturers of electrical infrastructure products and systems for transmission through to distribution and to the environmental systems and services in the built environment. I'll explain that better in a moment on the next slide. Some of the member companies are listed here on the slide, and as you can see, they are the leading brands or they represent many of the leading brands in our industry. We work with manufacturer members to ensure that their interests are well represented in the relevant political, regulatory and standardisation issues at UK, European and international levels. As you will see from the next slide, BEAMA's activities are divided into four main interest sectors or portfolios. So the four main interest sectors are building electrical systems, which Paul and I are representing tonight, heating and ventilation, networks, and also flexible energy systems. So as you can see on the slide, building electrical systems covers mains electrical distribution, sub-distribution and final distribution products, including cable management products. In other words, everything from a main LV switchboard right the way through to a light switch on the wall. Heat pumps, heating controls, underfloor heating, as you can see there, electric heat and vent, water safety and hygiene form the heating and ventilation group. The network group covers electrical products owned by the supply authorities, including high voltage equipment. And the flexible energy systems comprises of four groups, namely smart metering, electric vehicle infrastructure, building energy storage and connected homes. So you can see that this group covers the emerging technologies which are starting to gather more pace. So without covering every bullet point on this slide, in summary, here are some of the relevant activities which BEAMA are involved in, which have relevance to this evening's RCD presentation. Senior technical engineers, including Paul, in BEAMA form technical committees for their specialist product areas, whose task it is to support the maintenance of existing product standards and the development of new product standards, such as the BSEN series of product standards. These standards are required to ensure that products have a defined set of requirements to provide a safe electrical infrastructure. The British Standards Institute represents the UK at European levels through Senelec in the development of product standards, and likewise represents the UK at international level, IEC level. Members of the BEAMA Technical Committee regularly sit on BSI, Senelec and IEC product standard panels. The standards panels, whether at UK, European or IEC level, consist of government bodies, test laboratory representation, consumer groups, manufacturer and installer associations. So BEAMA's involvement in the wiring regulations is also worth an explanation. The wiring regulations are maintained and developed by a joint IET and BSI technical committee called JPEL 64, and that's electrical installations of buildings, which is coordinated by the IET. The technical committee for JPEL 64 consists of approximately 40 members from various groups, including government bodies, test laboratories, consumer groups, installer associations, and other trade associations, including BEAMA. Currently, BEAMA have 5 technical committee members on JPEL 64 representing different product areas. Participation in JPEL 64 is normally via a collective body, such as a trade association, and it is not normally possible for individual companies to take part in the development of new standards. The reason for the continued development of new editions of the wiring regulations covers a number of aspects. The wiring regulations need to take into account, and it is a requirement that the technical substance of agreements reached at Senelec level in harmonised documents are implemented in UK wiring regulations. The latest edition has been developed to enable our electrical distribution system to keep pace with the adoption of greater levels of technology. In terms of market surveillance and support initiatives, BEAMA is active in the area of identifying areas of non-compliance. As an example, in recent months, BEAMA were approached by an electrical installer who suspected that several thousand non-compliant wiring accessories had been pre-installed into off-site constructed units which were shipped into the UK. After testing, the products were confirmed to be non-compliant and were subsequently stripped out and replaced by a compliant brand. So moving on towards the main topic of the webinar, RCDs, we just wanted to start with the background as to how product standards are developing. As you can see, compliance is becoming much more complex. To comply with the low voltage directive, and that's CE marking, there is an increasing list of requirements to take into account. The product standard in this case for an RCCB is BS EN 61008. And it's just one of the requirements. Existing directives such as EMC, the electromagnetic capability regulation, REACH, that's the registration, evaluation, authorization and restriction of chemicals, and ROSH, restriction of hazardous substances, and new directives, including the recent changes to the WEEE directive, all have to be taken into account. As you can see, there are many other influences. As well as the requirements for the actual product itself, there are also the installation requirements. The current revision being the 18th edition of BS 7671. To coincide with the introduction of the 18th edition of the wiring regulations, BEAMA have introduced a freely available 40-page RCD handbook, which covers all aspects of residual current devices, including guidance to installers on the selection and application of RCDs. The companies listed on the slide have all contributed to the development of this handbook. Now over to Paul once again and to cover the next part of the presentation.
Thanks, Chris. Okay, so I just wanted to give you an overview of the family of products which makes up this generic term RCDs, or residual current devices, some of which you will know well, others may be lesser known and even relatively new to the market. To just run through them, we have the RCCB, or residual current operated circuit breaker without integral overcurrent protection, and the product standard is BS EN 61008. For RCBOs, that's an RCD with integral overcurrent protection, is BS EN 61009. SRCDs are not covered by a BSEN, but by a purely British standard, BS 7288, as are fused connection unit RCDs, also covered by BS 7288. And then PRCDs, or portable RCDs, again covered by a purely British standard, BS 7071. There is also a product called a CBR, which is a circuit breaker residual, or with residual current protection, and that's covered by BS EN 60947-2, and normally used in more commercial and industrial applications. And just going to the bottom of the next list, the Modular Rcd is BS EN 60947-2, and that's where the RCD is not built into one unit, but it's a number of different modules that is wired or connected together. The two new devices, which are relatively new to the market, is the ICCPD, which is an in-cable control device for protection of electric vehicle charging under Mode 2, and that's a BS EN 62752. And the RDCDD on the right-hand side, this is not strictly a residual current device, but it's a detecting device. It's not the same as an RCD per se. It is to detect 6 milliamp DC and open if it detects that level of current. Again, for use in EV charging, covered by BS IEC 62955. And the final one, just to mention, on the top right, is the residual current monitor. Again, not an RCD. It doesn't open when it detects doesn't open the circuit when it detects a residual current, but it just provides a monitoring service, either by an indicator or an alarm. And that's covered by BS EN 62020. So you can see there's quite a family of different RCDs to take into account. Okay. One thing I should mention about that previous slide is that Type F and Type B, which we'll come on to, are covered by another product standard, which is BS EN 62423, and that includes additional requirements on top of the RCCB and the RCBO standards. Okay, so now to the main substance of the presentation and a major change within the 18th edition of BS 7671. And that's the requirement to select the appropriate type of RCD dependent on the expected load. The relevant regulation being Regulation 531.3.3, and that requires that the appropriate RCD be selected from Type AC, Type A, Type F, or Type B. So it is quite a significant change within the regulations. These were not listed in previous versions of the regulations. So we're just going to go through the different types, and to take the types one at a time, we'll firstly briefly look at Type AC, and this is the product that will detect and open on an alternating sinusoidal residual current only. So it's whether it's sudden appearance or smoothly increasing, it will detect and trip on a sinusoidal current. But also you will see on the waveforms that we put on the screen, it's not just a pure sine wave. It is actually a sine wave where it's kind of switched or phase controlled or burst controlled, such as might be used on a dimmer circuit. So a Type AC device is suitable for these kind of waveforms as well, but it must be positive and negative so that you get an overall RMS value. The products are marked so that you can identify them, and for the Type AC, it is a sine wave in a box, and that will be marked on the front of the RCD. So that's a means of identification. The next RCD type to look at is Type A. This type is also common within the UK and has been available for many years. Type A RCDs will respond to alternating residual currents, just like the AC, but also to pulsating direct currents. This may be loads with electronic switching, such as chopped wave fault currents, such that chopped wave fault currents can be produced. An additional aspect of type A RCDs is their ability to continue to operate when there's a superimposed direct current of up to 6 milliamps. And this moves effectively moves the 0 point and can affect the operation of type AC RCDs, but will not affect the type A RCDs. For identification of type A RCDs, a sine wave and half wave in a box is shown on the slide. This is marked on the front of the RCD. Okay, so the next one is type F, and this is a relatively new product. Type AC and type A have been around for some years, even decades, but type F is relatively new. And this is to respond to the ever-increasing complexity of control systems. Type F RCDs will respond to the same residual currents as type AC and type A, but will also respond to composite residual currents of 10 Hertz, 50 Hertz, and 1 kilohertz. And this is really to accommodate complex currents, complex waveforms that are produced by some types of equipment. And again, in terms of identification, the product will be marked on the, as shown on the screen on the slide. I'll be marked with the two types of waveform, either side by side or one above the other. Sorry, just to point out, the waveforms on the right-hand bottom of the slide is just an example of the type of waveform or fault currents that the type F will respond to. So in the bottom right-hand corner, you can see a kind of it looks as though it's shaded, but it's actually a high-frequency AC waveform created by the control system. A type AC or type A would not respond to this type of waveform, but a type F will. And then the final RCD type to look at is type B. Type B have been available for many years, but are becoming increasingly required due to complex electronics and loads in some modern equipment. Such electronics and loads can create complex residual currents or even DC, smooth DC residual currents. The example waveforms given on the slide are typical of the types of residual currents that can occur. And it's very complex equipment, but with that level of switching, smoothing, and chopping, it does create very complex residual currents that AC, A, and F will not respond to. And again, in terms of identifying the product, they will be marked, as you can see on the screen, by either the side-by-side boxes or the one box with the waveforms above each other. And this shows the basically the type AC symbol, the type F symbol, and the DC symbol, which is for type B. Okay. And a couple of other points, important points to note with respect to type B RCDs. There is sometimes a misconception. Type B, although they are for use for detecting DC fault currents, they are not for use in DC supply systems. That's actually very important to note. It's DC fault currents they can detect, not for use in DC supply systems. So they are for use only in AC supply systems. Product standards for RCDs for use in DC supply systems are currently under development, but are not yet available. And the second point to note is RCD type B are not to be confused with type B circuit breaker instantaneous tripping. It can be confusing, but there is very different aspect to type B instantaneous tripping, and it mustn't be confused, particularly when considering RCBOs. A couple of additional requirements that have come in with the 18th edition of BS 7671. Firstly, it should be noted that luminaires must be protected by an RCD not exceeding 30 milliamps. Frequently for residential applications, this is already covered when using a dual 30 milliamp RCD consumer unit. But it must be recognised that this is not automatically the case, and care must be taken to ensure that this regulation is complied with. So you must check to ensure for new installations, for new circuits, that any luminaires are protected by a 30 milliamp RCD. And the other regulation that we'd like to point out is Regulation 722.531.2.101, where for electric vehicle charging applications, where an RCD is required, it shall either be a Type B, which was already in the previous version of the regulations, or Type A with appropriate equipment that provides disconnection of the supply in case of a DC fault current above 6 milliamps. Products complying with BS IEC 62955 meet the requirements for this additional appropriate equipment. So if you're using a Type A, you've also got to have a product to BS IEC 62955. Okay, now back to Chris for the next couple of slides.
Okay, thanks, Paul. So this next section relates to RCDs and expected loads. So Paul talked through the types of RCD, the AC, Type A, B, F, etc. We want to relate that to examples of the types of equipment or load that are applicable. So for the widely used Type A RCD, this provides protection for what can be considered as resistive loads. You can see these typical examples listed on the slide. We've got immersion heaters, oven stroke hob with resistive heating elements, electric showers, tungsten and halogen lighting. For Type A RCDs, they're suitable for all of the Type AC applications, but with the addition of being suitable for more sophisticated technology utilized in some modern appliances. And the appliances are as listed, and they include single-phase inverters, Class 1 IT and multimedia equipment, power supplies for Class 2 equipment, appliances such as washing machines that are not frequency controlled, e.g. DC or universal motor, lighting controls such as dimmer switch and home and building electronic systems, LED drivers, induction hobs, electric vehicle charging where any smooth DC fault current is less than 6 milliamps. And as stated before, Type A is suitable for all of the Type AC applications. So here we've got some examples of the Type F and Type B RCDs. We envisage that some modern appliances, which include, for instance, synchronous motors, may require protection with a Type F RCD. Type F RCDs are also suitable for Type AC and Type A applications. So as you can see there on the slide, frequency controlled equipment, some washing machines, dishwashers and dryers containing synchronous motors, some Class 1 power tools, and some air conditioning controllers using variable frequency speed drives. And once again, Type F is also suitable for all of the Type AC and Type A applications. A typical use for a Type B RCD is for electric vehicle charging, particularly where DC fault currents greater than 6 milliamps can occur. It must be noted that these are examples, and appliance manufacturers' instructions must be considered when selecting the appropriate type of RCD. And as you can see there under the Type B, which I didn't run through, there are a number of areas there. Inverters for speed control, UPS systems, electric vehicle charging, as I mentioned, where any smooth DC fault current is greater than 6 milliamps, photovoltaic systems, power electronic converter systems, typically industrial machines and cranes. And just to recap, type B is suitable for type AC, type A and type F applications. Now handing back to Paul again.
Okay, so looking at coordination, and coordination of the types of RCD is actually very important, because if you have the wrong type of RCD downstream, it can affect an upstream RCD. So where a number of RCDs are used in the same installation, it's very important that this correct coordination is applied. Whenever RCDs are installed in series, the upstream RCD must be at least the same type, or what could be termed a higher type. For instance, a type A RCD can only be downstream of a type A, a type F, or a type B. So if we took the middle section of this graphic that we have, where we've got type A with a downstream of another type A, you could not fit, or should not fit, a type B or a type F at the downstream position, because any fault currents that the downstream type F or type B detects could influence or even stop the upstream type A from working. It could have a significant effect on the performance of the upstream type A. So if again using the middle leg, if we needed a type F or type B, it should go upstream with the type A downstream. And if you you can see that with for the specific applications where type F or type B is needed, it comes off from the origin of the circuit rather than through another RCD. So it's very important that the correct coordination is applied. So basically, the upstream RCD must be at least equal or higher than the downstream RCD. Sorry, can we just go back? Can we go back on? Just to mention also that it must also remember that two RCDs in series, where there are two RCDs in series, as we have in this middle leg, selectivity must also be applied. So you would still need a time delay or type S RCD, S-type RCD, and a 3 times residual current on the upstream device. Okay, sorry.
Okay. So Paul and I have just covered areas of the RCD presentation, and as mentioned, we do have an RCD guide which is fully available. It's freely available. I believe it's on the NAPIT website anyway. It's fully available. You can also download it from the BEAMA website. But as part of BEAMA's available guides, we also have a guide to surge protection devices, SPDs, freely available now, and also a guide to arc fault detection devices, AFDDs, which are on the website as well. So I've included the links on the slides, but if the slides will be available to you all, but failing that, we can always get the links over to you via Matthew at NAPIT, no problem. So those are 3 guides that are available. In addition, we've produced technical bulletins on the following subjects, and these are also downloadable from our website. And first one is the coordination of wiring accessories, low voltage switchgear and control gear assemblies. The second one, technical bulletin, is for overload protection of an RCCB or switch. And the third is a technical bulletin on consumer unit 16 kA conditional rating application. So those are all available now. And other guides available. There's a host of things on our website, but you've got access to these guides, and it's an electrification by design series. And I mentioned earlier that we have a flexible energy portfolio, which looks at the newer technologies coming through, things like energy storage and smart homes and renewables. And these guides, they're all classified under the electrification design series, consist of smart homes by design, energy storage by design, electrifying road transport, and flexibility by design. You may find those useful as well. And finally, before the question and answer session begins, we'd just like to briefly mention that BEAMA have introduced a two-sided guide, or two-page guide. It's a safety checklist, and it's for miniature circuit breakers, RCCBs and RCBOs. And the reason for producing it was to help installers and electrical wholesalers to recognise the potential signs of non-compliant products on the market. We're getting some good responses so far from organisations regarding the use of it and making it available. And NAPIT have agreed that, well, have asked if they could promote this checklist, and you'll be able to see it soon, because it will be a subject in one of the forthcoming Competent Person magazines. So the details of it are in there, and it consists of 3 checks. Checking RCDs and MCBs, etc., for general quality indicators, other factors to consider regarding the route of purchase the channel is purchased from, and also the information provided on the front of the devices in terms of the characteristics of the device and what it needs to comply to and what information should be provided. So we think it's a helpful checklist.